Is that all that's, oh no, here, I can see. Okay, good. All right, how do I find the domain of A?
Set t equal to 0.
Not T. In other words, this quantity right there, that has to be positive or 0. In other words, I'm going to set t squared minus 20 has to be greater than or equal to 0. If it isn't, we're going to find ourselves taking the square root of a negative number. Okay? So whenever you see a radical sign like this, actually I should say a square root sign, because cube root is different. Square root, whatever's under that radical sign, then make it greater than or equal to 0 and solve it. Okay? Now, the solution is not necessarily obvious. What is the solution? How do you solve that? T squared is greater than or equal to 20.
You just square root of both sides.
Okay, so what do you get?
Square root of 20.
Okay, so you're saying one of the solutions is what? T is greater than or equal to the square root of 20? That's correct. But there's another solution. In other words, when you take the square root of both sides of an inequality, you got to be careful because the other solution is the opposite direction, like that. In other words, notice that if t was negative square root of 50, well then t squared would be 50. So that would work just fine. In other words, the negative number that ends up needing squared has to be greater than 20, greater than or equal to 20. And both of these work. It's a little bit like when you have an equation. If I'd have said t squared is equal to 20, well then t would be plus or minus square root of 20, correct?
Yeah.
Well, it's similar with inequalities, only more complicated. It's not as straightforward as plus or minus. I do have a plus and I have a minus, but it also, you have to change the direction of the inequality sign when you put the minus answer up. Now, square root of 20 simplifies to what? That's not simplified.
Let's see. Be 2 square root of 5.
Yeah. So really our answer is t is greater than or equal to 2 square root 5, or t is less than or equal to negative 2 root 5. Because when I square t, I got to put parentheses around that and square it. And that turns positive. Okay, let's go on to the next one. This one, what are my domain considerations for B? Do I care about the numerator?
No.
What's important about the denominator?
That there it's cubed root.
Not really. In other words, I can take the cube root of any number. I can take the cube root of 8, and that's equal to 2. And I can also take the cube root of negative 8, because that's equal to minus 2. So when you have odd roots, like cube roots or fifth roots, positive or negative numbers, in other words, all numbers, the domain for cube root is all numbers. There is, however, one further consideration. Your domain restrictions aren't just caused by square root signs. There's another more common way to have a domain consideration. What can you not divide by? First rule in math.
0.
Okay, you cannot divide by 0. So this whole thing cannot be 0. That is our only domain restriction. Well, what causes it to be 0?
2.
So y cannot be equal to 2. You could say, why? I'm not sure how they want answers here. Do they want everything in interval notation, or can you give your domains in various ways?
Yeah, they usually use interval notation.
Okay, let's put this in interval notation.
Be negative infinity, comma, 2, positive infinity, or no, 2, comma, positive infinity.
After the 2, you kind of need to specify whether it's a parentheses or a bracket.
Parenthesis.
Okay, because sometimes it can be a bracket in combination with
2, comma, positive infinity.
Okay. And maybe we ought to go back and do this one in interval notation. Remember what we got? We got t had to be greater than or equal to 2 root 5, or t had to be less than or equal to negative 2 root 5. Let's put that in interval notation, because that's maybe a little tricky. Not really so much, but I want to make sure you know how to do it.
See, that'd be negative infinity, then comma 2 square root of 5 with a bracket.
Hold on. When you go from left to right on the number line, you come to this number first. So it's not 2 root 5, it's negative 2 root 5. With a bracket. See what I'm saying?
Yeah.
Okay, in union with what?
Bracket 2 root 5, then positive infinity, and then close the parenthesis.
Perfect. All right, infinities always have parentheses. Number C, that is a polynomial. Does it have any domain restrictions?
Yeah, it will have 3.
What are they? Tell me what x cannot be.
That's it can't be 0.
You want to think about domain restrictions as being what can x not be. Not so much what can x be, it's what can x not be. In the last one, we figured out what could y not be, and only because it was in the denominator. The numerator had nothing to do with it. And here we figured out what t cannot be. Well, we actually figured out what t could be with a. But whenever you're looking at a polynomial, there's no restrictions on x. In other words, I'm not taking the square root of anything. I'm not dividing by anything. In other words, x can be all real numbers. Did they let you answer that?
Yeah.
Okay. So you don't always have to say negative infinity to positive infinity?
No, you don't have to.
Okay. So a number D. What's the only restriction on z?
-4.
Okay. And I will assume that you can do the interval notation and we'll just go on. Number E. Oops, excuse me, I left out the negative sign. Yeah, z cannot be equal to -4. Any other number is fine. Ooh, hold on a second. Not sure that's true. Yeah, it is true. It is true. I was thinking because these two are the same, we really have 0 divided by 0, and sometimes that's allowed. In other words, sometimes that turns into something else. And in this case, that would turn into +1 occasionally and -1 occasionally. Wow. But that restriction never goes away. Even if I had this, if I had z plus 4 over z plus 4, and it was just like that, okay? I can convert that to the number 1, and now it looks like there's no domain restrictions at all. But there is. There is a hole at z equal -4. In other words, if I'm graphing that thing, I know it's a straight line, y is equal to 1, but at -4 there is a hole because of this part. That doesn't go away just because you divide the two. So that restriction is going to stay with that same problem, just like that. All right, where is our restriction coming from on E? In other words, why would E be restricted? What is it about it that is going to restrict it, the domain?
The numerator or the exponent?
Yeah, the natural log of t. Well, logs are more restrictive than square roots. I can take the square root of t, I can take the square root of 0, rather, but I can't take the log of 0. I definitely cannot take the log of negative numbers. So what is the interval notation answer? Not for that.
T must be greater than or equal to 1.
Now give it to me in interval notation.
It'd be parentheses 0, comma,
No.
positive infinity.
Excuse me. Yep. Positive infinity. Yeah, exactly. But not bracket. In other words, if I was listing the domain for that, it would be bracket 0 to infinity. But natural log, you cannot even do it to 0. All right. Let's go to 2. Okay. Think about this for a second. How am I going to do this one? The fact that I'm looking for something that's parallel, and in the next line I'm going to be looking for something that's perpendicular, what are they getting at? What do I need?
The same, like x and y value.
Slope. Slope. Whether you're in calculus, pre-calculus, geometry, or algebra, slope is where it's at. And when they're talking about parallel, that means the same slope. So let's generically figure out what the slope of this line is. In other words, they didn't give us any A, B, or C, but I can still solve for slope. What do I have to do to that to solve it for slope?
Make everything equal to y.
Okay, solve that for y.
It'd be y equals ax
Negative
minus,
ax. I got to move the ax to the other side.
then plus c all over b.
Okay, let's do that in 2 steps. It's all over b, or I can do it like that. Okay, and this has a little bit better advantage because what's our slope? What's our slope?
Negative a over b.
Negative a over b. So that's the slope we have to duplicate if we're trying to draw a parallel line. What's our y-intercept?
C over b.
Okay, and it's asking that this be passing through the origin. So what does c over b have to be?
To -1.
No, we're doing it part A only for the moment. You're looking at part
0.
B. Okay, so c over b has to be 0, which means c has to be 0, which means that doesn't work. So there is the equation of our line for number A. That is parallel to this line, and it's guaranteed to pass through 0 because the our standard is y equal mx plus b. That's the y-intercept. So whatever that is, and don't confuse the b in this general format with the b here. They're not the same b. And this is a capital B. But even still, when I put it in y equal mx plus b format, that is the y-intercept. Okay, now our slope is minus a over b. So find an equation of a line that is perpendicular to the given line. So what does that mean about the slope is going to have to be? That was the slope of the parallel. This is the slope of the perpendicular.
It has to be the inverse.
Give it to me.
B over a.
Okay, you did 2 things there. Not just the reciprocal. You said inverse, but you meant reciprocal. Not the same thing. And you have to change the sign. So whenever you're looking at the perpendicular slope, remember you got to not one thing. So there's our slope, and we have to pass through that point this time. So what am I going to do next?
Set y-intercept equal to -1.
No, that doesn't mean, in other words, we could have a line that just has to pass through that point. Okay, that point is right there. Well, I could have a lot of lines pass through that point. I could have that line, I could have that line, I could have that line. They each have different y-intercepts. So I'm not setting b equal to -1.
You substitute in for the x and y.
Yes. In other words, we know what M is. M is B over A. And we have a point that has to satisfy that equation. And in that line, the y value has to be minus 1 when the x value is 2. So I'm going to put minus 1 equals b over a times 2 plus little b. And it's little b that we're solving for, so that we can put it into the equation of the line. Now, they purposefully make this confusing, but let's solve for little b. How do you do it?
You move B to the left.
Move that whole thing to the left.
Okay.
That's a number. In other words, b and a are constants. They're non-zero constants. Okay? So it's all I got to do to move that to the left is subtract it. So I end up with the slope being, or not the slope, little b being that is equal to little b. Now, let's give the equation of the line. There's the general format. Let's fill in everything we know. There's only two things we need to know are m and little b. In other words, when we go back and give the equation of the line, we are filling in for that. What is that? What's m?
B over A.
And what is little b?
The whole thing, negative 1 minus 2B over A.
Yeah, it is, for the moment, I'm going to put a plus sign because it's plus little b. But little b ends up being that minus 2 that over a. And now I can essentially, if I want, you know what, I kind of like leaving the answer as that. I could remove the parentheses and just leave the negative sign there. I guess I like that answer better. That. In other words, I'm going to remove the parentheses and both negative signs get left. Whenever you're adding something, you can do that. And even though that doesn't look like the standard equation of a line, it is. In other words, that is little b, that is the slope. So it is actually it is in y equal mx plus b form. That, in other words, if we knew what capital B and capital A are, that's going to convert. All right. It's actually a pretty good problem because you have to kind of know everything. That's 2 weeks worth of an algebra class right there. That one problem. I've made that drive a few times from Phoenix to Tucson. It took longer to get through Phoenix than it took to get from Phoenix to Tucson.
Yeah, I know.
It did. It took me two full hours to get just through the city because the traffic was so snarled. This was like 10 years ago. I don't know if they've improved it much since then or not. So, distance from, okay. When is the driver 40, notice the scales. Whenever they give you a graph and they're asking you questions about it, first thing you want to make sure is you know what the horizontal scale is and what the vertical scale is. So now it becomes clear. Okay. So when is the driver 40 miles from Tucson?
at d equals 80, the 80 on the graph.
But it says when is the driver.
Oh, okay.
So you're correct that that is the 40 miles from Tucson.
So 90 minutes.
Hold on a second, just a second. That vertical graph says distance from Phoenix. Okay, and at 80 miles from Phoenix is 40 miles from Tucson. Okay, and so 90 minutes is the answer. In other words, that's why when they're asking you questions like when, you know they're asking about the horizontal scale. When is the horizontal scale at a certain point on the vertical scale? Okay. What is the speed of the driver over the last hour of the trip? There to there.
It'd be 80 divided by 1, so 80 miles an hour.
Write a piecewise function for this function. The distance from Phoenix as a function of the number of minutes since the beginning of the trip. Well, think of this as they gave you a graph and you got to write a piecewise function of it. Okay? Well, I can see two pieces. I can see this piece here and I can see this piece here. So we're going to need two pieces to our piecewise function. The first piece is going to be when t, and I always start in the upper right. In other words, I specify the domain. When t is greater than or equal to 0 and less than or equal to 60, what is the equation of that line? Put it in this format.
Y equals what? 20 over 30 x plus b.
Where are you getting? Oh, okay, 20 over 30. Okay. So 20 over 30 is 2
So 2/3.
x.
And then plus 0.
Okay. So that's the equation of the line when we're between 0 and 60. There's an equation of the line when t is greater than or even equal to 60. Perhaps we ought to say on here, use 0 to 120. All right, so t is between 0 and 120. Okay. I should have written that a little bit more consistent here. Let me do that. Now notice I used the equals also, but that's okay because at that point right there, both equations cross. So they'll be equal at that point, regardless of which equation I use. Now, I'm going to move that a little bit further to the left so I have a little bit more writing room. It's the equation of that line. The most immediate problem is what? You can't figure out what?
Would be, let's see, it'd be 40 over 30.
Okay, 4/3, that's the slope. The immediate problem is that I can't tell where the y-intercept is, correct?
Correct.
It doesn't go through the y-intercept. I could extend an imaginary line, kind of figure out where the y-intercept might be, but that's not the way to do it. There's an easy way to do it. We have the slope and we have a point. There's any point along that line will work. Let's use this point right here. So if we have a slope and a point, how can I solve for b?
It'd be 40 over 60. So 4, 6.
Yeah, I wrote the wrong equation, sorry. So here's our equation. I'm going to write over here on the left side. So y equals 4/3 x plus b, and we need to solve for b. So we put 40 in for y. 40 equals 4/3. We put in 60 for x, and that's going to let us solve for little b. That cancels with that, leaving 20, producing 80. Little b is minus 40. So the equation of the line is 4/3 x minus 40. So you don't necessarily have to cross the y-intercept to be able to figure it out. As all you need is slope and one point. If you know, I could have used this point up here. I could have used that point. I could have used any of them. As long as I knew the slope and one point, then that specifies where it would cross the x-axis, or the y-axis, excuse me. All right, let's see. Let me scroll here a bit. What is that noise in the background?
It was a motorcycle, I think.
No, there's some, maybe you can hear a lot of noise. Sounds like it could be an interfering.
Oh, it's a leaf blower outside or something. I think. I don't know, I have headphones in.
I can't identify it. That's why it made me think it was almost static. It's just on our GoToMeeting line here. All right. Water is being pumped into a tank at a constant rate. Sketch a graph of the height of the water in the tank as a function of time. Assume the tank is initially empty and will be filled. You want to hear that?
No.
Sounds like a wild bear groaning.
Oh yeah,
that's weird.
It could be the leaf blower or something outside.
On my end only. No, it doesn't sound like a leaf blower. That's a pretty constant sound. This is kind of like a haunted house with a ghost making noises. All right. What do we need to know to answer this question?
Need to know the area of...
Not the area.
The volume of the...
Volume, and the key is that right there. Cubic feet per minute. That is a measure of volume. Oh, it is the air blower. Now I hear it. Yeah, it is the air blower. Okay. All right. So what is the volume of figure A?
It'd be pi r. Or no, it's 1/2 pi r squared.
No, it's It's the area of the base. This is a prism.
Times the height.
Times the height. Or in this case, this dimension. That's the height. Whether it's on its side or not doesn't really matter. It's going to matter actually for our equation. Okay, now cubic feet per minute. That's a graph of the height of the water tank as a function of time. Now on this one over here, the water line is going to go up like this, right?
Yeah.
And it's a graph of the height of the water. So the height of the water is this measure.
The diameter.
Yeah, think about this for a second. This almost looks like a calculus problem, but it isn't, is it?
It could be.
It could be. Have you had this kind of calculus in this class?
Well, we did it at the beginning of the year. This is for 122A.
The reason I say that is that when you're talking about a rate, that is dv dt. That's what a constant rate water's filling it at filling that volume, constant rate. We want the height as a function of time. This is a calculus problem. Okay. We know that the volume of that cylinder, is it possible that this, let's see if I can solve it with calculus. I'm going to implicitly differentiate both sides with respect to t. Okay, and what that gives me is this. Hell no, it doesn't. I got to use the power rule. I mean, not the power rule, the product. Okay. R and H are not related. We haven't been told their relationship. So they're definitely two different variables. So if I did use the product rule, let's go back and use the product rule here. In other words, it's the product of that times that. And they are both variables of time. So this might work because the radius is going to change with time for the diameter of that base. And the height, this, that is a constant. It does not change with time. See, here's the problem. What we've called h isn't really the height. Yeah, we gotta change our picture here. Better to start with B. because with B, this is height. And it's not over here. In other words, over here, what we're calling the height is the distance between that and that. But as we fill this thing with water, what they want to know is the height of the water, not the thickness of the cylinder. We've got to be very careful we don't confuse the variables we're using. Over here, I can get away with it because the height is going to be the height. In other words, as we fill this thing with water, it'll get there first. So we'll be able to figure out this one without calculus, I think. God, I got to just think about this for a second. The volume of the water is IR squared times H. So every minute, wow. We may have to come back to this one. I may need some time to think about this. I don't feel like it should be a calculus problem. So far, we haven't seen any calculus problems at all. And as I look further on, those aren't calculus problems either. So I don't feel like this is a calculus problem. And water is being, I'm going to have to think about it. It might be a calculus, and I have to think about it as a calculus problem to solve it. I can't think of how to solve it without bringing in calculus. I'm not even positive I can solve it with calculus, but let's get back to number 4. This is just for review for a test, right?
Yeah.
All right. We'll get back to 4. You got more sessions coming up here. Let's just go on while I'll give myself some time to think about number 4. All right. This is talking about proportionality. If I tell you y is proportional to x, what does that mean? How can I write that? Y is proportional to x. Directly proportional to x, excuse me. But directly proportional pretty much means the same as proportional. But if I said y is directly proportional to x, what do you start out with? Remember k?
K is the rate then?
No. K is a constant, but this is what it means to be directly proportional. If I say y is inversely proportional to x, then x is going to be in the denominator, but I still have a k in the numerator. And k will be different for every one of these problems. You can think of 1,000 different things that are directly proportional. And you can think of 1,000 different things that are inversely proportional. How each one of them is going to differ is each one of them will have a different k. Okay? So this is always where we start when we talk about being inversely or directly proportional. We start there. Okay, so they're saying the lift is proportional to the square of the speed. That's what that looks like. Of the plane and the area of its wings. So there's the equation. If they would have said, and inversely proportional to its weight, then I would have divided the whole thing by its weight. But they didn't say that. Is all they said is it's directly at takeoff is proportional to the square of the speed, that's s squared, and the end means that it's also directly proportional to the area of its wings, and those two things have to be multiplied together. In other words, this is a joint proportion. L is jointly proportional to S and the square of S and A. And that's how you write that, is they're being multiplied. But never forget the K. The K is some number that we're not going to be able to figure out, but because they haven't given us the information. In other words, if they told us the lift was 100 pounds when S is this and A is this, then we'd be able to figure out K. But they aren't giving us that. So we can't figure out K or expect to be able to figure it out. Write an equation for lift. Well, there it is. If the speed is only half as much, how much larger should the area of the wings be for the lift to be the same? Well, K doesn't change. Lift is the same, so L doesn't change. What changes?
The S.
Okay, and it becomes 1/2 S squared. And A is going to have to change. What does A have to do? In other words, what do I have to do to A to make this the same as that? This now becomes K S to the fourth, S squared over 4. What does A have to be to make it that?
4A.
4A. It has to increase by a factor of 4. Now the 4's cancel, and I'm back to my original equation. So what they're trying to point out is that because it was proportional to the speed squared, that's the more important variable, is the speed is more important than the area. If you cut the speed in half, you got to make the wing size 4 times bigger to get the same amount of lift. If you double the speed, you can make the wing, the area, a 4th. See, that's not a calculus problem either. I gotta believe that other thing is not a calculus problem. My brain is confused with thinking of it in non-calculus and calculus ways. I'll think of it though. Suppose that R is a function of a person's age. It means I could write it like this. When I write it like this, I'm only going to find one thing on the other side of the equation that's a variable, and that's A. Okay? Now, they also added the rest of this stuff. But they're telling us that these are all constants. The only variable is that A. Everything else is a constant. H sub O is a constant, P is a constant. So the only thing is A. Find the slope and give a practical interpretation of it. Well, r of a, we can call that y, right? And we want an equation. If we can put it in this format, they're asking, what is m? So how do we put this in this format?
You add the, or no?
Yeah, well, you're right. I can add the h sub o. Thinking maybe there's a better way to do this. Now, but before we add it, let's distribute it. No, we can just add it over there. I'll add it right here. Okay. Now, at least we're getting closer. We have y equals all of this stuff over here. Well, our variable is a. So what's the next thing I need to do?
Distribute the p.
Yeah. So what does that give me?
220 p,
Which is a number. P is not a variable.
minus a p.
Let's put the a there because that's like x.
And then minus p h of, or the h.
Okay. What's the slope?
220.
No, rewrite it. Remember, p is not the variable. P is a constant. The variable is a. They're really trying to fool you here because usually a capital letter is a constant and little letters are variables. And they're switching it up on you here. But person's age, it's a function of the person's age. So our variable is age. So let's rewrite this equation in this format. Right now it's not in that format. We've got a number in front. We've got our variable as the second term, and we've got these two numbers way over here. Let's write it in y equal mx plus b format. Y equals what?
So b,
Put this first.
so minus p a.
Okay, that's the mx, right? Everything else is the b. Everything else can be combined as a number. Every one of these is a constant. That means it's the number. So all of that is little b. But they're not asking about little b. They're asking about slope. The only thing they wanted to know was slope and then give a practical interpretation of it. Well, what's the slope?
Just a,
No, a is the variable.
then minus
It's like
p.
telling me the slope up here is x. What's the slope in my standard general format?
Minus p.
Okay. M is the slope, minus p is the m. So our slope is minus p. That answers the question. Now find the slope and give a practical interpretation. Well, what does slope tend to mean? Rate of change, right? And they're saying that p is a number. Of course, it doesn't have to be a positive number, although since minus p is the slope, Let's draw a graph. Sometimes it helps to draw a graph. This is the target heart rate as a function of age. Therefore, this is age. And they're saying the slope is minus p. So this thing, the target heart rate declines as you get older. That's what they're saying. This would have made a little bit more sense if they had said H sub O and P are positive constants, because just saying it's a constant, what if P was a negative number? Then negative P would be a positive number. But nonetheless, I think that's what they mean, is that H sub O and P are positive constants. But I'm pretty sure that just knowing life, that the younger you are, your target heart rate should be higher. In other words, if you're exercising and I'm exercising, we're not both trying to achieve the same target heart rate. If I tried to achieve your perfect target heart rate, I'd probably have a heart attack because it would be too high for me. Whereas you, being younger, can get a faster heart rate that you're going to shoot for if you're a runner or whatever. If you're exercising just for exercising's sake, then you tend to try to get to your target heart rate. And this is merely saying that that goes down with age. Whatever P is, say P is 2, then goes down by 2 points for every year you get older. I suppose you could say it goes down by P. The interpretation is it goes down by P amount for every year you get older. That's what the slope, a negative P slope, means. All right, let's see. That's probably a good place to stop. Zach, these problems tend to be pretty hard, and this next one looks like there's multiple parts to it, so we don't quite have time. I don't want to get halfway into it.
Okay.
Next
I
time,
have to.
pick up with 7 and probably 4. By next time, I will figure it out. Okay?
Works for me.
All right, Zach. Have a good day. Talk to you next time.
Yep.